I'm not sure why I wrote calculator at the top of this problem. We do not need a calculator for any of it. I'm not sure if it came from a calculator part of an old calc test or what. Um, but anyway, no calculator. Let f be a function having derivatives of all orders for all real numbers. The third degree Taylor polynomial for f about 2 is given by this. Find f of 2 and the second derivative at 2. So remember, the actual function value at 2 is the constant term in the equation. So we know that f of 2 is equal to 7. But to help me with the second derivative, I think it would be smart to write out what the generic t of x formula is before getting these simplified results. So remember, we're centered at 2. So t of x is equal to f of 2 plus the first derivative at 2 times x minus 2 plus the second derivative at 2 times x minus 2 squared over 2 factorial plus the third derivative at 2 times x minus 2 to the third over 3 factorial. So again, I can just kind of line these up and say, well, if this is the case, then f of 2 has to equal 7. And again, for the scoring guidelines, all they have is f of 2 is equal to t of 2, which is 7. So again, if you plug 2 in, all of the non-constant terms drop out. What about the second derivative? I like having it for this reason. So we know that the second derivative at 2 over 2 factorial, that coefficient in front of the x squared simplifies to just -9. So when we're solving for this, it's not that the second derivative is just equal to -9. It's that the second derivative, if you solve for it, at 2 is equal to -18. So that's a pretty common question of they're checking to see if you remember that factorial was there before it was simplified away. Is there enough information given to determine whether f has a critical point at x equals 2? A critical point, remember, means when the first derivative is equal to 0 or undefined. If not, explain why not. If so, determine whether we have a max, min, or neither locally. Justify your answer. All right, so I am looking through what I have expanded out for t of x. This will help me here too. Notice there is no x minus 2 to the first term. That's because the second derivative must be 0. And it does say that f has derivatives of all orders, so I know that it's 0 rather than undefined. So is there enough information to say whether we have a critical point? Yes. Make sure you answer your yes or no for those questions. Yes, there is a critical point at x equals 0 because f prime of 0 equals 0. Now you could explain because t of x has no x minus 2 to the first term, but I don't think that you have to there. And then do I know whether this is a relative max, min, or neither? So I can't use first derivative test, which is what we usually default to. Remember, we usually say, oh, put the critical points on a number line and test for f prime and see what happens. But we don't have any f prime equation here. We just know one value of it. So we have to go back to the second derivative test, which is what we used in problem number 11. So remember, we can say if we have concave up, then this horizontal tangent at 0 tells me we have a relative min, and if it's concave down, if f is concave down, then we have a relative max. So take a look at the second derivative. We just said the second derivative at 2, which was equal to -18, is less than 0. So f of x is concave down. Write that out on the AP test. Write the words out, concave down at x equals 2. So scenario number 2, I always have to draw these for myself, and you can draw them, and no one's grading this portion of your paper. So that means that there is a relative minimum. No, relative, see, I need that picture. Relative maximum. Just Just writing things now. At x equals 2. Relative maximum, hence the picture. All right. Part C. Use t of x to find an approximation for f of 0. So let's just do that to start. F of 0 is about equal to t of 0. And that would equal, let's go back up to their simplified version. Get this so I can see both. There we go. So that would equal 7 minus 9 times 0 minus 2 squared. So 4 minus 3 times 0 minus 2 to the third, negative 8. 7 minus 36 plus 24. So what is this? Negative 29 plus 24. So f of 0 is approximately negative 5. Now there was more to this question. So is there enough information to given to determine whether f has a critical point at 0? If not, explain why not. If so, tell whether it's a max, min, or neither. So go back to what we did on part B. There was enough information because we had in part B, because we had f prime of 0 equals 0. But for this, we would need to know at x equals 0. Oh, I'm sorry. Back here, we knew that f prime of 2 equals 0. I wrote that correctly here, but not here. Sorry. So what we would need for this problem is f prime of 0, and we don't have that information. So there is not enough information. There's not enough information to determine a critical point at 2. And that's because t of x only uses f prime of 2, f n of 2 information. Sorry, I miswrote that in part B. That was f prime of 2 equals 0 for that derivative. Okay, and then part D. The fourth derivative of f satisfies this inequality. Anytime they give you this inequality, what they're telling you is that's the max value of the fourth derivative at x, or z, or whatever. They're not using z right here. They're just saying x. Use the Lagrange error bound in the approximation to f of 0 found in part C to explain why f of 0 is negative. So let's find Lagrange error. Now remember, in part C, we used a third order derivative or a third order polynomial to approximate at x equals 0. That should be less than or equal to the fourth derivative of x. Remember, this is like z, and z is between 0 and 2. But because they just called it fourth derivative of x, I'm just going to use that too. If you put a z in there, you've got to put some little statement about how z is somewhere between 0 and 2. But anyway, fourth derivative at x times 0 minus 2, our approximation minus our center to the fourth power, over 4 factorial. So what is this value? Now, we were just given that the max value for the fourth derivative is 6. Negative 2 to the fourth is positive 16. And 4 factorial is 24. So we can reduce this a bit, quite a lot actually. So the remainder at 0, how far off are we? Plus or minus our approximation is 4 units. So that means that the actual, I'm going to say therefore, f of 0 is equal to our approximation plus or minus 4. And so that puts f of 0 between negative 9 and negative 5 plus 4 is negative 1. So explain why f of 0 has to be negative. this shows that f of 0 has to fall between two negative numbers. So I'm just going to say f of 0 must be negative. Because remember, Lagrange error is a maximum error. It's an error bound. So we're saying this is like worst case scenario, but the actual value is probably even less than 4 off. So we know that f of 0 has to be negative. And that was the end of this problem. A little bit longer.